Everyone. Today I'd like to discuss a data science project, basically data analytics project, uh, which I've done on Excel, and this is a problem statement. So basically, we have a data set from an insurance company where we have details regarding age, their gender, BMI, number of children they have, whether they smoke or not, and which region do they belong to, and what are the yearly charges that they incur. So this is the data set. And first of all, whenever we start any kind of project, it is very convenient to convert any kind of data set into a table format. So the best option is to just click anywhere and press Control plus A and then Control plus T. So you get a table, and here you can see what are the ranges of different parameters. Like children, we have 0 to 5 children. For smokers, we have either no or yes. For charges, it varies. Like it's from 1100 and it varies up to 63,000 per year. So basically, this is the data set. Now, once we go to the problem statement, it asks us to calculate the average, median, and the standard deviation. So basically, I've already done all of this after converting it to a table, and then I've also added a few more columns. And then if I go to this chart where I've calculated the average, median, and standard deviation, this is for question number 1. So if you look at the formula, so we'll just go to the formulas and we'll see the show formulas tab. So what I've done is I have named my table insurance, and the medical charges, that column of the medical charges is named as medical charges. So I'm just calling the function average by referring the insurance table and the medical charges column. So it just gives the average. The same is for BMI and standard deviation. The functions that I've used is average, median, and standard deviation. Once you switch off the formulas, we see that on an average, the medical charges are 13,000 and the median is around 9,000 and the standard deviation is approximately 12,110. So basically, it's a very diverse data set. It is not very compact or precise. And since we have a range of people from where the data is collected, so the standard deviation is also very high. Like we already saw that the average, not the average, the minimum value that the person spends is approximately 1100 and the maximum is approximately 63,000. So it varies by a ton. Then again, for BMI, we have values from the average is 30.66, the median is 30.4, the standard deviation is 6.10, and for the age, we have a standard deviation of 14.5, 14.05, and the average and median is approximately the same. So yeah, the formula that you use here is average, and simply you call the column for which you want the average. And let's go to the next question. The next question is compare the average medical charges in the BMI between male and female beneficiaries. So basically, this is a comparison between the male and female gender, and we want to compare the values which are medical charges and the BMI. So in this case also, we are using a variant of average, which is average ifs. So in case of average ifs, what we do is we do a calculation on a particular column if a criteria is fulfilled. So in this case, what I've said is this is male and female. I've just written it here because in our column, the genders option says, I'll show you the our data set. So the sex is either female or male. So if I refer to this column and I check, oh, if this is a female, I'll do the average for this. So that's the same thing which this function does, averages. So let's look at the formula again. So in this case, I have said average of the insurance of medical charges. That means average of this, excuse me, average of this column, medical charges, if the sex column is equal to B17. In this case, it's male. So if the sex column is equal to male, then the average will be performed over that particular data set. That's what average ifs do. It basically checks whether statement is correct or not, and then does the average if the criteria is fulfilled. In this case, the value has to be male. Similar is for female. Here I have referred B18. So B18 is the female value that I put here. And the same thing we have done for BMI charges. So in this case, if I just remove the formulas and look at the comparison, it looks like the male value is a little bit higher than the female. So which is 13,000, approximately 14,000, and the female is approximately 12.5 thousand dollars. The BMI is also a little bit higher for males, but it's not a very significant difference. For the next question, we have done for smoker versus non-smoker. You can see that in this case, I'll again show the formula. So in this case, yeah, we are doing the average of the over the medical charges if the smoker column is equal to G17, which is equal to yes. So that's the formula. And if I look at the value here, you can see that on an average, if you don't smoke, you spend approximately 1/4 of what the other person spends on. It is a very significant amount of difference that we have seen is present in this particular data set. So the first three questions are done. Let's go to the, yeah. So the first three questions, you can also do it using pivot tables, but I found it convenient since we only had two values. Uh, Dependent analysis is like that for the number of children, we want to see whether the correlation, whether any kind of correlation is there, or whether there's any kind of line from line chart where you can see any trends using trend lines, etc. So we'll see what happens. So once I go to the question number 4, so we want to check if there are particular number of children. If a person has more children, then he either spends more or less as compared to the person who has lower number of children. So this is the kind of analysis that we want to do. So one of the ways is to just do a scatter plot, like for children against the cost. So you can just do it like you click on these two columns and then go to insert and add a scatter plot. You get the same data, but it does not give a very you know uh, very distinct idea that what's happening. Since the data points here, the number of data points here are very large. 1, 2, generally more people have 0, 1 or 2 number of children, and very few amount of people have like 4 or 5 children. So on an average, you can see that okay, there might be some kind of trend which is kind of decreasing in the way, but unless and until we have sufficiently large number of data sets here as well, a good correlation could not be concluded here. But let's go on and see what is the actual correlation value that we get. So if I directly calculate the correlation between the number of children and the medical charges, the value comes out with 0.06. I've just used the Correl function here, which in Excel calculates the correlation between two numerical columns. So in this case, it's 0 to 5, and then there are a lot of points there, and then there are medical charges. But another thing that I found convenient is if I get the average get the average for each kind of data set. So for a person who have no children, on an average, how much do they spend, right? And this goes on till if a person has like 5 children, how much do they spend on an average? So I've just calculated the average for each and every category. And you see here that, okay, fine. If I go to 0, 1, or even 2, it's not arranged. Let me sort it. Okay, it's connected, so we cannot change it right now. I can shift it manually, but we'll see it later. So for 0, it's like 12,000. For 1, it's 12,731. And for 2, it's almost 15,000. So basically, it keeps on increasing up to 2. From here, this graph, it is clear, more clear. So it keeps on increasing up to 2. And then for 3, it is almost the same. And then it keeps on decreasing, right? And then if I get the correlation for this value, specifically, correlation between these two, we get a negative correlation of approximately 0.3, which means that if you have higher number of children, you spend less, which is not actually true, because from the trend you can see that initially it increases and then later on it decreases, right? Initially it increases slightly and then the decrease is very high, and the decrease is high, that's why the correlation is minus 0.3. But you can see that the data points, the number of data points for 4 and 5 are very low. So if we have sufficiently large amount of data sets which is in comparison to these, then only we can make any kind of conclusions regarding the same. Otherwise this question is just left hanging. But there seems to be some kind of correlation, but we cannot exactly confirm it yet. Let's go to the next question. Next question says determine the US region which has the highest average medical costs and BMI. Create the pivot table and the chart that summarizes the data by region. So for creating pivots table, it's very simple. You go to your table, you click anywhere on the table, and you go to insert and you click on pivot table. And you can either add this data to the model. By adding this data to the model, you actually can create measures. But then there are some constraints also which comes along with it. For now, just leave it blank and click on OK. So here you get parameters of fields and you can drag it to various rows and columns. Like suppose if I want to check how many male and female members are there, you can click on values and you get the count of females and males. So for our question, which is like determine which US region has the highest average medical costs and BMI. So for this I've already done an analysis, just show you. So in this case, in this pivot table, I have dragged the region to rows and the values of medical charges and BMI to the values. And here, through conditional formatting, you can see that the southeast region, you can uh, you can get conditional formatting by clicking here, go to home, get conditional formatting. You can color your scales, or you can get the top and bottom values here. So I have already done it, and I've highlighted these values based on the, since both of them are maximum in their own column. And this is approximately 14,735 and this is 33.36. That means for one particular region, southeast, the average BMI is also very high and the average medical charges is also very high. You can also see it through this plot, which shows that the highest value is 14,735 and the BMI is also. So this plot I've actually, I'll just show you how I plotted this. You go to pivot table analyze. You can also do it from the data mod, from the home insert tab. Here you can go to columns or even recommended charts, and you can do a combo here. You can say that okay, fine, the line has to, the BMI has to be on the secondary axis, then only you can compare these two. Otherwise it will be very if it's on the same axis, the value is very low and it will be just close to zero, so you cannot see anything. So yeah, the highest area the highest medical charge is for Southeast, and highest BMI is also for Southeast. If I go to the next question, it says the cost distribution analysis. Create a histogram to visualize the dependence of medical charges. Identify the most common bracket. So to create a histogram, what you do is you select your column for which you want to create a histogram. It's generally a column which is numbers. Okay. So basically a lot of numbers of people, like suppose you have 100 children in class and everyone has age between like 8 to 15. Now you want to classify how many people lie between 0 to 8 to 12 and 12 to 15, suppose. So in this case you will draw two columns in which you will categorize your data. So that's the same thing. So to draw histogram, you just click on the table that you want to do analysis on and then click on histogram here. You get a tab, and since the bin size is very squished, and generally we don't want these number of bins because we want the clarity and we want to target the segments. So basically it's a good idea to just use the bins. So you go to format access and you can select your bin width. Generally if the value is this much, you generally choose around 10,000 for one bin and then click enter. You get values like for the first $10,000, and most of people are spending less than $10,000. And then you can also add label to your data. So yeah, 781 people are from the range of 1121 to 11,121. So this I've already done in this plot, and yeah, you can also see that there are 7 people who spend more than approximately more than 50,000 in a particular year, right? There's another way to do the same thing, categorization, which I've done here. So using if else statements, you categorize your values. Like suppose if this is between 16,884, you can say that it lies between 10 to 20,000, and I have created a category. Now you can do a simple column chart by selecting this and sorry by doing a pivot analysis. So basically you go to pivot table and you do the same thing here. So I've categorized those data and I have created a count of those columns, and then I have plotted this. So it more or less gives the same value, same answer, that is less than 10,000 is approximately 712. It was here, it was approximately 11,121 and it's 781. So highest value people spend less than approximately 10,000. Let's go to the next question. Next question says classify the beneficiaries into BMI categories and underweight. So basically we have to do a category wise analysis. So using the same if else statement or if statement, IFS statements, you can do a categorization here. So you go to the column or the table that we have, and then what we do is we create a new column using the if statements. So if the BMI value, which is this value, I am referring here to the BMI column, is less than 18.5, it is underweight. If it is less than 24.9, it is normal, and so on. So I've created these categories, and then what I do is I just go to the pivot table analyze. So go to insert, go to pivot table, and then here we have BMI category, and then we can get the count of BMI category. So this is the count of BMI category, and then we can sort it. So sort from largest to smallest, and we get most of the people are from obese. So this I've already done, and I'll show you the chart that I've created. So this is normal column chart, and it gives the same thing, like 719 people are obese. And I've also done a conditional formatting here. So yeah, most of the people are obese. The question was, count how many beneficiaries fall into each category. Yeah, done. So let's go to the next question, advanced correlation analysis. Use the scatter plot to analyze the correlation between BMI and medical charges. Add a trend line to the scatter plot to access the relationship. Okay, so in this case, what we do is, sorry, for doing a scatter plot analysis, we need two columns which are numerical in nature. So we have BMI and we have medical charges. And you go to insert and you go to scatter plot, you get a scatter plot, and you can add a trend line here, which is this, and you can also edit the trend line. Go to this column here, you can display the R squared value, you can display the equation values, and here we get a correlation between BMI in the x-axis. This BMI and this is the medical costs for each data point. But you can see that in this case, this trend line does not give a lot of information regarding the data point. One of the major reasons that you can conclude whether a trend line is good or not is with the R squared value. R squared, if it's very low, it is not a good fit and does not give much sense into the data. But we cannot overfit also this data, because the approximation has to come from the physical ideas as well. You cannot randomly put a power of multiple measures and then you say that the data is already fitted. So it has to make sense. So what I did here was, I thought that there are two kind of data sets here, like one for smokers and the other for non-smokers. So I separated both of these data and did a correlation diagram for both of them. So I've just used a normal filter. I've created a filter here where the smoker is no, and then you get a trend line. Here the R squared value is very low, which is like 0.0071. This means that there's hardly any correlation between the BMI and the medical charges for people who don't smoke. But if you go to this plot, which actually shows a correlation and a high R squared value, if I just increase the size here, you can see that the R squared value is approximately 0.65, which is decent. When you have R squared values approximately 0.99 or 1, it is considered the best. But it's almost impossible to achieve that in a practical world. Here it is 0.65, which means it's a decent correlation between BMI and medical charges. This for conclusion, what I did was I used a correl function to get the correlation between these three values that we got. So for overall, if I calculate the correlation, here the data set is total data set, the insurance column and the medical charges column, both of them are 0.2, the correlation between them. For non-smokers, it is 0.08. Here I have created a filter which says insurance smokers is equals to no. But for yes, the value is 0.81, which is highly correlated. So this was a good analysis, a good question, and I thoroughly enjoyed it while doing it. So the next question is, uh, yeah, investigate the interaction between the smoking and region based on medical charges. So again, the same, we have to do the same pivot plot analysis, a pivot table analysis, and here we have filters which are slices which are not yes for smokers, and for region also we have this. I've created a kind of double donut chart, and here also you can see that for the southeast region, for the smoking values, the people who are smokers actually spend the maximum on medical charges, and for the northeast, the non-smokers spend the maximum, which is 9,166. Here also you can see that 27% of the expenditure which goes into the medical charges are coming from the northeast region, and here it is approximately 28%. For the last question, we are going to see about the dashboard creation. So I've created a dashboard. I'll just show you the thought process, how I created it, but I'm not going to go into much details here. So it is just an interactive dashboard. So basically what I did was I first created a pivot table. Just a sec. Yeah, this is the pivot table. So basically I've done a rough work here kind of. So I've calculated the median age, average medical charges, and I also created these measures. Like, these are the functions that I've created. For average medical charge, you can click and you can see that edit measure. You can create a DAX formula, and from here you can calculate it manually. Not manually, it's automatic, but yeah, it is much more precise. So basically, this is the rough work that I did, and then I have created these whole data sets to slicers, and created it to connected it to another sheet which is in dashboard. So basically what happens, if I zoom in, if I change anything here, like the first value, the bigger value gives the average age of the whole data set. The same is for this average medical age for the whole data set, average BMI for the whole data set, median dependency for the whole data set, and the lower value is for the things you select using the slicer. And this is BMI category versus medical charges. This is dependency versus charges, count of male versus female, and the number of smokers that we have in the data set and non-smokers, BMI versus charges, and here you can click on any value and you can see the data set changes. Earlier the value was approximately 13,000 here, now it has changed to 8,400 because we have clicked on smoker equals to no. If I again click here and I want to see for another region, you can click here and you can see that okay, fine, this changes. So it's basically an interactive dashboard where if you want to get into the details of how the behavior occurs, you can see. Thank you.